Good afternoon, everyone. This is our last lesson of the year. I know you're sad. This is lesson 7.8 over applications of logs. Applications meaning story problems. So before we start, we got to learn about the actual formulas we're going to use. There are some other formulas that will be used in logarithm applications, but these are the three that we're going to concentrate on. So if you look, the first one's called growth and decay, y equals ne to the kt. If you're in chemistry, you probably have seen this problem, or you definitely have talked about growth and decay. The second one is continuously compounded interest. We're not going to compound quarterly or monthly. We're just doing continuously compounded. So that A equals PE to the RT. You probably use that in middle school. The last one is the value of equipment and assets. So V sub n, and the n doesn't really mean anything. It just means what's the value. It's just a subscript. There's nothing to plug in for n here. Equals P times the 1 plus R to the nth power. This n is what we plug into. Now, over on the right-hand side of the table, you will see that we have what each of the variables stands for. But one thing I want to let you know, if you look at the y, the a, and the v sub n, they're all on the left side of the equal sign. This stands for our ending amount. Those values are what we're ending with. The initial values would be the ones on the right side of the equal sign. This is our initial values, what we begin with. E is E. We talked about E when we did natural logs. K is a constant. It is a constant, so they'll either be given to you or we would have to find. T is time. R is an interest rate, and if you remember, R is written as a decimal. Okay, let's go ahead and get started. So if you look at number one says for a certain strain of bacteria, K is 0.775. So first of all, without reading any further, you have to make sure you know what equation to do up above. This is about growth and decay because it's talking science, bacteria. So we're going to actually use y equals ne to the kt. So if you go back up to the top, you'll see it is the first equation. Okay, we're going to fill in our information. We know K is 0.775 when T is measured in hours. How long will it take 2 bacteria to increase to 1,000? So you ask yourself, why is the ending amount? So what is my ending amount? Well, it's 1,000 bacteria. What was my beginning amount? Well, my beginning amount is 2. E is still E. And then K is that 0.775. And then T is what we're trying to find. Okay, so the very first step on all of these equations is you have to get the exponent part by itself. So I need to divide everything by 2. So when I divide everything by 2, I get 500 equals E to the 0.775t. Now, a couple ways you can do it. You can take the ln, and the reason it's the ln is because there's an e there of each side, and move the power down, or just switch forms. I still think switching forms is the easiest way to do this. So we're going to go ln, and my base is e from right there. We're going to go across the equal sign to get the 500, and that equals 0.775t. So the ln of E of 500 is just the ln of 500. So if you put that in your calculator, you get the decimal 6.2146. And that equals the 0.775t. Then if you divide each of the sides by 0.775t, I get t is 8.02 years. and don't round to the nearest whole. The 0.02 affects your answer. Okay, the second one is Jackson. I need to erase a little bit here. Let's see. Okay, erase that out of the way. Okay, so number 2 is Jackson deposited $100 in a savings account. Well, savings account will introduce you to money, and the money is going to be the second one. And if you're not for sure there, if you look here at the end, it says interest compounded continuously. Okay, so he just withdrew the entire balance of $200. How long ago did he open the account? So let's use A equals PE to the RT. Well, A is my ending amount. If you remember, we withdrew the entire thing, which is $200. P is my beginning amount, which is the $100 he deposited into savings. E is E. My interest rate we're going to use as a decimal, and we're trying to find how long. So we're trying to find T. So again, we're going to isolate the E, so we're going to divide everything by 100. So we get 2 equals E to the 0.06T. We're going to switch forms again, so the ln, the E comes down, and we go across to get the 2, and that equals 0.06T. ln 2 is just a decimal, which is 0.6931. And we're going to divide it by the 0.06, so I get T equal to 11.55 years. That would be the answer to number 2. Number 3, let's go ahead and erase this part again. Number 3 is going back, and we're talking about radioactivity substance. Well, that kind of reminds me of chemistry again. So that would be the Y equals NE to the KT. Okay, this time it gave you negative is for K, and that means it's going to be a decay. So your ending amount should be smaller than your original amount. So the ending amount, the sample will reduce to 50. So we get 50. Oh, sorry. 50 equals N, our initial value is 250. E is still E. K is negative 0.08042, and then T is what we're trying to find again. So again, we're going to divide by 250, and when I do that, I'm going to get 0.2. So you get 0.2 equals negative 0.08. I'm going to go back. Forgot my E, didn't I? You're going to go E to the negative 0.08042T. We're going to switch forms. So we're going to go the ln of E of 0.2, which is in our calculator, negative 0.08042T. When I plug that into my calculator, I get negative 1.6094 equals negative 0.08042T. Divide by negative 0.08042, and I get T is 20.01 years, and that would be the answer to number 3. Okay, now if we go back and look at the next one, again you see bacteria. So that tells you you're going to go back up, and we're going to use the Y equals NE to the KT. So you get Y equals NE to the KT. You're starting at 500 going to 4,000. And since they gave it to us in minutes, and they don't say anything about changing it to hours, if they did change it to hours, we would have to change the 90 minutes to 1.5 hours. But you're going to give a answer for K this time, so let's work through this one. So the ending amount is 4,000, beginning amount is 500, e to the 90k. Well, this time you're going to divide by 500, and when I divide by 500, I get 8 equals e to the 90k. We're going to switch forms, so you get the ln of e of 8 equals 90k. ln of 8, so if I want to, if you don't want to put the decimal in, you can just divide by 90, and then you can type this whole entire thing into your calculator. Probably make sure you close your parentheses after the 8. So I get K is 0.023, which is positive, so that means it is growth. And if you look, we went from 500 to 4,000, so we most likely did it correctly. Okay, let's go down to number 5. This time, Charlotte is investing $1,000 in a certificate deposit 3 years ago. So we know time this time. The CD is now worth $12.76. What we're trying to do is find the interest rate. Well, it doesn't say anything about compounded continuously. I take that back. There it is right there. So we are going to compound continuously. I'm going to change the color here. So we're going to use A equals PE to the RT. So we ended with 1276. We started with 1,000 E. The interest rate is what we're trying to find, but we know it's 3 years, so 3R. Again, divide by 1,000, so you're going to get 1.276 equals E to the 3R. Switch forms, I get ln of E of 1.276 equals 3R. So I'm just going to go ahead and divide by 3 and put this whole entire thing in the calculator. And when I do that, I get R equals 0.0812, but we need a percent. So if you remember, we got to move it over 2 spaces to the right because we multiply by 100, 8.12%. And don't round any of these answers. I would take everything out to the hundredths place. Okay, and the last one, you're probably wondering why we haven't used the last formula. Well, here we go. The last formula talks about equipment. The last formula is only used for physical equipment. Everything else is one, scientific, and number 2 is anything financial that is not a physical piece of equipment, land, house, car. So I know CDs are something you can purchase. Sorry about the dogs. Shh. So we're going to use the bottom one. So if you look, the bottom formula says V sub n equals P times 1 plus R to the nth power. Shh, ladies. So you get V sub n equals P times 1 plus R to the nth. And I'm going to double check. Notice I don't have these memorized either. You don't have to memorize them. These would be given to you if we were in the classroom. V sub n stands what the value at the end is. So it's now worth 5,000, so it would be 5,000. P stands for the initial value, well, it was 25,000. But this one depreciates. Now, we didn't talk about that up in the formula. So at the 1 plus R, if it appreciates, it's plus. But if it depreciates, then that means it goes down, and we have to use 1 minus R. So we're going to put 1 minus R to the nth power, and the nth power is what we're trying to find. So R is 10%, so we have to change that to 0.1. So then we have, this is 0.10. Okay, so now we got to do a little bit of math. We got to get the power by itself, so obviously we're going to divide by 25,000 again. And we're going to get 0.2, and that equals 1 minus 0.10 n. Well, we can simplify that, so you get 0.2 equals 0.90 to the nth power. Now, if you notice, there's no e. So no e, so we're not going to do not ln. We're going to take the logs. Okay, so I'm still going to switch forms. So if we go log, the base is 0.9. We go across the equal sign to get 0.2, and that equals n. If you remember, this is called change of base. So we're going to go log 0.2, the number, divided by log of the base. And that equals n. And I get 15.3 years. And that is our lesson. So hopefully that helps you guys. You can get through it. The first worksheet that we're doing this week is all story problems front and back. And the second worksheet we'll do for review next week has a little bit of review, and then it has 1 page of story problems. Talk to you soon.